This is a quick tutorial answering a request from a user on how to create adjustable track lighting with RailClone. To follow this tutorial, you'll need RailClone 4 or above, but the first part of the tutorial can be completed with the free Lite version. For the more advanced version seen at the end of the tutorial, you will need RailClone Pro. And also just to mention, this tutorial only deals with the geometry. It's not yet possible to distribute lights with RailClone. Not yet. Let's get started. First of all, you'll need some geometry. Now this isn't a modelling tutorial, so we won't go through that process. But it is helpful to understand how many pieces you should split an object like this into, and why. So where possible, think about dividing any design into smaller, more manageable sections. In this case, I planned the rail section and the light section separately. The rail could consist of as few as 2 pieces, one bracket piece and then the metal strip. To make sure that this all aligns correctly in RailClone, the pivots for both pieces should be aligned at ceiling level. If you're using RailClone Pro, you could also have 2 additional pieces for the start and the end, since you have the ability to use more segments. And then the second part, the light fittings. In RailClone Lite, you'll need to use a single object. This will allow you to randomize the rotation on the Z-axis, but the other angles are fixed. If you're using RailClone Pro, you can split the light fitting into 2 parts. A top section and bracket that can be rotated on the Z-axis, and a separate light so it can be rotated on the other axis. The first segment has its pivot adjusted so that when it's aligned, it sits on the track correctly. The light itself has its pivot adjusted to the position we'd like to rotate it around. So let's assemble these pieces into a new style, starting with a version that's compatible with the free Lite version. So create a new RailClone object and open the style editor. Create a new linear or L1S generator. Add a spline node and select any spline from the scene. Wire the spline node to the spline input and then let's import the geometry. Create a single segment node. Right click on it and choose Clone Multiple. From the new dialog box, select the geometry from the scene and just click Clone. And this is a nice fast way to import lots of things quickly. Wire the bracket segment to the start, end and evenly inputs. Then go into the Alignment Z option and set it to pivot or top so that it sits just below the spline. For this section we'll turn off bend and slice. In fact, the only segment that should bend in this style is the rail itself. Then to adjust the spacing of these evenly segments, you use the distance parameter. To ensure that all the spaces are the same size, turn on Adaptive. If you don't turn this on, the first and last spaces are averaged, and then the remaining ones in between are exactly the value set in the distance property. To make this style easier for people to use, right-click on the generator and export the evenly distance. Then you can attach a new numeric node and you can change the mode to scene units. This property, as you can see, can now be controlled from the Modify panel. And this is an ideal technique when you want to create styles that you want other artists to use, or if you simply don't want to open the graph every time you need to make a small change. Nearly any parameter can be exported in this way. Wire the rail segment to the default input. The geometry in this input, essentially it fills in along the spline anywhere that's left after the geometry in the other inputs has been applied. So here it's just filling in between the evenly start and the end inputs. But as you can see, we need to change the Z alignment to pivot so that it snaps together correctly. So you'll notice that also the rail stops short of the brackets, and this is because RailClone uses the bounding box of the geometry to calculate adjacencies. There are a few ways we could fix this, but in this example we'll simply tell RailClone that this segment is much smaller than it actually is for its calculations. And to do that, you go to the bracket segment and enter a very small value for the fixed size X property. And as you can see, this will flatten the geometry, but by disabling Scale Segment, only the bounding box used to calculate adjacent segments is scaled, the actual geometry itself is unaffected. Select the light hole segment, disable Bend and Slice, and change the X, Y and Z alignment to pivot. To add this, we will also need to use the default segment, since we want it to be between the evenly segments, but there's already a rail in there. So let's create an alternating pattern of rail then light using a sequence operator. So wire a sequence operator to the default input and then wire the rail segment to its first input. Next, wire the light segment to the second input. Change the sequence operator's mode so that it resets after each evenly segment by selecting Reset at Spline Section. And a spline section in this context is an area of the spline between two of the non-default segments. So an area of spline between the start and the evenly, evenly and evenly, or evenly and end, for example. Finally, set the fixed size to a small value and disable scale segment to force the rail to continue to the center of the light, just like we did earlier with the brackets. Okay, so far so good, but the spacing is a little too regular. To fix this, we can randomize the length of the rail segment. Add a transform operator between the rail segment and the sequence operator, turn on fixed size, and then right click on the transform node and export X fixed size. Wire a random number node to this newly exported input. Change the mode to scene units and adjust the minimum and maximum value. And then finally change generate on to segment. So now we've got some randomized spacing, but this is another setting we might want to change regularly. So we can expose it in the modify panel, just like we did for the evenly distance. So right click on the transform node and export minimum and maximum scene units. Create two new number nodes and wire one to each of the new inputs. Change the mode to scene units, and then don't forget to rename them so that it's clear what they do in the modify panel. Now you can see if you adjust these, you've got control of the spacing. So far so good, but there are some occasions when you might get overlapping segments, like you can see here. To fix that, wire a conditional node after the light segment and wire the light to the true input. Wire the rail to the second input, false input. And then you can change the conditional node settings so that it only returns true, which will mean the light is used, if its position is less than 95% of the current spline section. So a section is an area between a start unevenly or two evenly segments. Okay, so finally select the light segment and enable transform random rotation. And for the Z-axis enter -180 minimum and 180 maximum. And that concludes the light version of the lighting style. It has adjustable spacing of the lights and the brackets with randomized light rotation. And that's pretty cool, and if that's all you need, you can stop right here. But if you have RailClone Pro, you can take it a little further and randomize the rotation of the light on the Y-axis as well as the Z, and also add different start and end pieces. So let's carry on. First of all, import the alternative start and end pieces if you haven't done so already. Set their alignment Z-axis to pivot and wire them to the start and end inputs where appropriate. Delete the existing light hole segment, we're not going to use that. Instead, wire a compose operator to the true input of the conditional operator. Change its mode to grouped. This mode will align the segments based on their pivot points, rather than putting them next to one another based on their bounding boxes. Wire the light bracket and light segments to the compose operator. And then let's add some randomization. So wire a transform operator after the light bracket segment. Right click and expose Z fixed rotation. Attach a random number node. Set the minimum to -180 and the maximum to 180 and change generate on to segment. Great, now duplicate the transform operator and attach it after the light segment. Both these segments, because they are sharing the same random node, will both be rotating together. You can see the light itself is in the wrong place, it's too high up. We couldn't change the pivot because we need to rotate around that, so we'll move the light into position by changing the fixed Z translation value instead. So to randomly rotate that light on the other axis, we'll create another transform node and wire it immediately after the light segment but before the existing transform operator. You can now use the fixed Y rotation property to angle the lights, as you can see. So let's randomize this value by going through the same process again and exporting it, and then attaching a random number node. Set the type to float and use a minimum value of -90 and a maximum value of 90 in this case, because we don't want them to point at the ceiling. So the way that I like to think about this sequence of transform operators in RailClone 4 is to imagine them being processed backwards. First we randomise the rotation on the z-axis, afterwards we randomise the rotation on the y-axis. And you can imagine if this order was reversed, you wouldn't get the desired results. Okay, so finally we need to fix the alignment and the gap in the rails. To do that, wire a new transform node after the compose operator. Set the alignment for all axes to pivot, and change the fixed size to a very small number, just like we did earlier in this tutorial. And that's it, style's finished. In this tutorial we looked at 2 ways of creating track lighting, but many of the principles explored in this video can also be used in many other types of objects. And remember, this was created by request, so if you've got a question you'd like to see explained in a short tutorial, just let us know on the forum or in the comments below this video. Thanks, and stay tuned for more coming soon.